Now I want to talk about Metasploit. And Metasploit is made up of a bunch of modules with payloads, and then it can open up sessions on the various systems that you're targeting, and it can do things like creating a remote shell or reverse shell that then you can effectively have a console that will allow you to control that system or access files and other processes on there. So what is a Metasploit framework? So it's an open source exploitation framework that has thousands upon thousands of exploits, payloads, auxiliary tools, and it has a single interface, and that interface is all terminal based. And so now as a penetration tester, you don't have to write the exploit code for every CVE. Someone else may have already written it. Now, if there is a new exploit out there, you can write a Metasploit module and get it uploaded to their library so that other researchers can then download and run that same exploit there. There is I believe it uses Ruby on the back end to run the exploits, and I think it stores everything in a PostgreSQL database. So it's a modular architecture, so it contains those exploits, various payloads, encoders, things of that nature. MSF console is going to be that primary interface. So in Kali Linux, you can just launch this by opening up a terminal and just type literally MSF console, and it will load Metasploit. It's shipped, ready to use. It already has it on Kali. If you're doing this on a different system for some reason, there is a lot of ways of installing Metasploit and configuring it. Kali is just designed for this type of work. So different type of modules. There's the exploit module. So this is the code which will take advantage of a specific vulnerability. So homework, I believe it's homework 1 or 2, I can't remember which one, will actually have you exploit Eternal Blue on a Windows 7 machine. So you would end up using exploit /Windows/SMB/MS17_010_ Eternal Blue. Payloads is after there's a successful exploitation. This is the steps as to how it would open up a reverse shell, have I think it's pronounced Metasploit session, but basically it's a command line interface that you can then navigate through that particular session. And then auxiliary will have supporting functions that aren't those exploits. So there's scanners, fuzzers, login brute forcers, protocol probes. One of the things in the lab is there's an auxiliary one for testing VNC passwords. And so there's a Metasploit auxiliary module that you would end up using for that. Post is modules run after the session is established. So this is where you can get those privilege escalation checks, credential harvesting, persistence that we'll talk about later on, and pivoting and lateral movements through networks and that sort of stuff. There's the encoder, which will transform bytes or payload bytes to avoid those bad characters, evade symbol signature-based detection, various other ways of encoding that data, so it doesn't all have to be just UTF-8. And then there's the no operation instruction. So no ops will typically come in, especially for those buffer overflows, where you need to have a certain number or certain amount of data which is sent there, and typically you end up sending a lot of no operations as part of that to kind of pad the attack payload. So what can you do inside of the console? So you can search for various exploits. So once you have the MSF console open, you can just type search space whatever you want. If you're looking for a specific exploit, then you can do type :exploit Eternal Blue, or if you know the CVE, you can do CVE : and then the CVE information, or you can just type Windows and it will list everything that's in there for Windows. Once you find a specific module you want to use, then it's literally just use space that module name. It sometimes can take a second to load it up, but then it will change the prompt to indicate that you are actually in that module. Once you're in that module, you end up having to set a couple of options. So you can type show options to list all of the various options for there, but at the bare minimum, you have to set the rhosts variable, which is the remote host that you're going to be connecting to. Sometimes you have to set the lhost variable, which is your local host. Sometimes it will default to 127.0.0.1. The problem will be that when you're trying to set up a reverse shell, then it's going to try to set it up to that IP address, and the other system can't access that. So normally you have to set and change the lhost to your Kali virtual machine IP address. Some exploits do require you to change the payload. I will say that in the lab that you will end up having to do, there is one vulnerability that you will have to try different payloads to find one that will actually work. If you don't make a change to it, then it just won't work. You can do show targets to kind of see what targets it's going to be attacking, especially if you have multiple rhosts. Once you have that, then you can go ahead and check to make sure that it will actually work. And that verifies if the target is vulnerable. So in the case of Eternal Blue, check will go through and see, okay, is SMB v1 enabled? Can we connect to SMB v1? If so, then it is likely vulnerable to this. And then exploit will actually run the exploit code, and if everything works, then you will either get a reverse shell or you will get other information from that particular exploit. And so you'll do this for all sorts of different types of vulnerabilities and ways of attacking systems. So understanding the payload types, the naming convention is going to be the stage, and then the architecture, then the technique, and then the delivery method. So Windows x64, Metasploit, and reverse TCP for that. So typically there's some singles which are self-contained, exploit and payload in one, no second stage to download, so those are just going to be a single thing that are run. There are stagers which will have a smaller initial payload. Once you get that connection back, then it will run a different larger stage payload there. A stage is going to be the full payload downloaded by the stager after the connection is established. There's a bind which can open up a listening port on the target and wait for the attacker to connect to it. So a lot of times these are like a netcat reverse shell or something of that nature. And then, well, reverse is the payload connects from the target back to the attacker's listener. So that's a way to bypass various firewall rules. So you will get exposed to all of this through the homework and through the lab. So it will start to make a lot more sense as you do it. So like I mentioned, Eternal Blue, and this is what the homework will have you do. So once you load the MSF console, then you just type use exploit Windows SMB MS17010 Eternal Blue. Once it loads that, then you would have to set the rhost. So if that, I have a Windows 7 VM which is distributed with this, so you would have to look to see what the IP address is, but you would probably set rhost 192.168.56.104, for instance. Lhost, that'll be your Kali VM IP address, so that'll probably be something like 192.168.56.101 or 102 or something like that. Payload, you don't necessarily have to change the payload for this particular one, but you can also show payload or show payloads, and it will list out all the possible payloads. And you can experiment and try different payloads, see how each one works and whether it works or doesn't work. And so if you wanted to change payload, you would just say set payload, either the string for that, or if you show the list of payloads, it'll have a number in front of that, and you can just do set payload, that number. Once you have that, then you can do a check, and that will check to see if it's potentially vulnerable to this. And then if it is, just type exploit, that's it. And once you exploit it, then you have a access to that system through a shell. So SMB v1 or Eternal Blue was a buffer overflow attack. It was really, really bad because it bypassed the Windows firewall. It bypassed all sorts of security. Pretty much every single Windows system was vulnerable to this once it was discovered. In fact, the Windows VM that I am distributing is it's a base install Windows 7 home, and no updates or anything. And all I did was turn off the firewall. That's it. So everything else was stock standard from the Microsoft install. But it was a buffer overflow, which was triggered remotely, and then delivering the staged payload over a reverse TCP connection. And once you have that, then you have system level access to that particular system. So you want to make sure that you always run that check before the exploit where supported. Not all exploits have a check, but a lot do. And that just is an extra step to say, yes, this system is potentially or probably vulnerable to this particular exploit. Once you have a successful exploit, then you can do a lot of stuff, and you can list the sessions, and you can interact with a specific session. So once you're connected to it, and you may be connected via different methods, you can switch between those different sessions. You can background that current session, so you can do things on your local system, and then you can foreground it. You can run a module afterwards. So for instance, the Eternal Blue, once you get connected, then you can run the hash dump to gather all the hashes from that Windows system. So then you can kind of crack the various accounts or see the various user accounts which are enabled. You can upgrade to a basic shell. You can run a command on every open session at once, list background jobs, and you can kill various sessions. So capabilities, once you have a session, it's really up to you. You can grab files, you can upload or download files, you can start or kill processes, you can harvest those credentials. So one of the things that a lot of people starting out don't realize is that Windows stores credentials in memory and in files on the system in kind of an encrypted manner. So there's the local SAM database, which will have the hash credentials. Mimikatz will allow you to recover plain text credentials from memory. So if you manage to get connected to an administrator's workstation, which may have domain admin access on a network, well, potentially you can get domain admin access on that same network. There's also privilege escalation helpers. So once you log into that system, you may only get connected with a normal user. But once you're connected with a normal user, that system may then be vulnerable to various privilege escalation attacks. And so there's a lot of utilities out there which will help you in trying to escalate your privileges. And then you can also route traffic through a compromised host. Once you can get connected, then you can kind of direct that system to do almost whatever you want, depending upon what your permission level is. So being able to route all network traffic through a system that just captures everything is quite a dangerous thing to be able to do. So best practices, use the Metasploit database, DB status, host, services, and credential commands persist, and everything is discovered, which is essential for keeping a multi-day engagement organized and for report generation. Stay inside of your scope. You don't want to exceed whatever bounds of authorization, and so you want to stay inside of that scope. So make sure that our host matches that target list, and you don't just give it a really broad range, which is beyond the scope. Well-tested Metasploit module with check command is safer than raw unverified proof of concept code. Again, you want to test it on your VM. You want to effectively create a mirror of whatever you're wanting to attack as well as you can. Make sure that stuff works on that, and then try it on the actual system. Ultimately, log everything and document everything, because, well, having that documentation is proof that if something goes wrong, well, you did it a specific way that should not have caused that. And then at the end of the day, you want to clean up after everything. You don't want to leave files behind. You don't want to leave processes running. You want to get in there, verify that it's vulnerable to this through whatever methods are necessary, and then clean up and get out of there and leave the system as you found it. So some key takeaways. Metasploit has those packages, payloads, auxiliary tools. The workflow is the same. You search for systems or you search for vulnerabilities, and then you can identify a target, then search through Metasploit for those vulnerabilities. Then you can use those exploits. Then you can use those exploits. You would then show the options, set various options, set the payload if necessary, run a check against the system, and then exploit. And the payload naming tells you the target, how it connects. It has its own interface after you're connected to then allow you to do all sorts of stuff to that particular system. And then you can also control and manage multiple sessions and jobs for that. And then ultimately confirm that you're always in scope, run the check before the exploit, log everything, clean up everything, and leave it as you found it.